handy spreadsheet, and we just do it so y'all can see it, not that y'all have to use it. Copy. Pull up our handy dandy spreadsheet. Vanna decided not to show up today. Can't find good help these days. We just cut class. And we'll put it right here. And there's our X and P of X. Okay, now the first thing we need to do is we need to take X and multiply it by what? P of X. So that's going to be equal to that times that. What's different about this column? Not different about this column. Must be the. Well, I'm not going to worry about it. And add those up. And what is that called? Mean. What else do we need? Well, we need X squared, right? And that's equal to this quantity squared. I always have somebody say, well, Hubert, you can do that in your head. Yeah, you can do that in your head, but are all these going to be whole numbers all the time? No. Yeah, and they may not be decimals because you don't have 3.2 events, but you may have 27, 28, 29, and 30. And unless you're Rain Man, you're not going to know what 27, y'all know what 30 is. 30 times 30 is 900. But you don't know what 27, 28, 29 are unless you're Rain Man. So, you know, get in the habit of actually doing it on the spreadsheet or in your calculator so you know what to do. You go through that motion. And then take X squared times what? P of X. Make sure you pick the right column. And add those up. And that's part of your variance. And that's going to be equal to this guy minus what? The mean squared. And that's your variance. Your standard deviation is equal to that number raised to the 0.5 power. And there's your numbers. Mean goes in the middle. Add one standard deviation. And add another standard deviation. Subtract the standard deviation. And subtract the standard deviation. So your normality falls between what? Negative 0.5 and 2.9. That's normality. So let's take a look at our handy dandy problem. No offense, but I don't trust y'all. Y'all set me up. So, all right, round to 2 decimal places. So that'd be 1.17. It's a miracle. 0.85. Is it unusual for a family with 3 children to have only girls? Well, only girls. Which one is this one up here? Only girls. Is that, let's see, assume probability child having X girls. Okay, so this is only girls is how many cents? 6 cents. What is the unusual representation? 5 cents, right? So is 6 cents greater or less than 5 cents? So then 3 girls is what? Normal or unusual? If it's more than 5 cents, it throws it into what? Normality. It throws it into the normal. Less than 5 cents, it's in the what? It's in the 2 wings over here, which is unusual. So 3 girls is what? Normal. So make sure you read this, because a lot of times I've answered the wrong question. Put the wrong answer because I didn't read the question. Is it unusual? No. So you got to say no. So it's either B or C. And which one is it? C. So I know y'all can read. Good. Check answer. Look there, we got it right. It's a miracle. All right, now you should have 3 or 4. Count in your notes if you don't mind. I think it's 4, but check. Okay, you should have 4. And 4 is good enough for a test. So, and if you don't have 4, if you wasn't here, go check the videos out. You'll be the only person that does. All right. Let's do another. Let's move to another section. So let's go to 5.3. 5.3 and 5.4, whichever sections we're supposed to cover, are real simple because we don't have to do anything but use a calculator. For some of you that's on the calculator drill team in high school, y'all will like that. NP and X. Probably what we're going to go over next. Let me get rid of this and move over. Yep, that's what we're doing, NP and X. Might want to write down page 211, the green box. Just make a note of that. Tells you what the different variables are. All you're going to need basically is N, P, and X. N is always like N in here would be 25 because there's about 25 students in here. All right, so N would be 25. That's your big number. X denotes a specific number of successes in N trials, and P is going to be your percentage, okay, or probability. Percentage, probability, area, all those are the same thing. So NP and X. Most of you that's going to use the TI, well, that's all you need to know, NP and X. Because Q is going to be the complement of P. So if P is 0.5, Q is going to be 0.5. If Q is 0.6, if Q is 0.6, P is 0.4. So, and your formula is probably on the next page. There it is. There is the formula. Now you talking about a pain. You thought that the permutation and the combination formula was a pain to do by hand. This one's even more of a pain to do by hand. So I would suggest borrow a TI, or make sure you get an app for your phone for the TI. One of the two, because it's a pain. n factorial over n minus x factorial times x factorial times p to the x power times q to the n minus x power. And that is a pain. Or you can use your handy dandy NPX. And I'll show you where that is. So unless you don't have any access to a TI, you might want to write that formula down. And I'll give you an example. Let's say that you flip a coin 10 times, and no, let's say you flip it 100 times, and you find out that it's a little bit weighted toward tails, because out of the 100 times that you flipped it, 57 of them became tails. In other words, it fell on tails. Alright? Then you ask yourself, what is the chance, what is the probability of this coin getting on tails if you flip it 10 more times? Alright, so you got a coin, you flipped it 100 times, you got 57 out of 100 tails. And they're asking you, what is the probability that if you flip it 10 more times, the same coin, what is the probability that you're going to get tails out of those 10 times? So that's what it's asking. So your N would be 100, your P would be 0.57, and your X would be 10, because you're going to flip it 10 more times. Alright? So that's the kind of question that they're going to ask. If you have this, and the probability of this, what is the probability if you do this with the same coin or the same die or the same deck of cards or whatever? That's what they're asking. So, as far as this goes, I would not suggest using this unless you positively, absolutely do not have access to a TI. You do not have access to an app for TI. Then you would have to use this. Okay, so that means if you have access to a TI and you know your neighbor, don't let them borrow it for a second. Okay, because they don't need to do this by hand. It'll take them 15 minutes to do it because it's aggravating. Okay, not only are the exponents aggravating, but you have to deal with these factorials, and without the TI, that would be a pain. So, calculator drill team, y'all can be proud. Alright, here's an example. Given that there is a 0.85 probability that a randomly selected adult knows what Twitter is, use the binomial probability formula to find the probability of exactly 3 adults who know what Twitter is. When 5 adults are randomly selected. So N is equal to 5, P is equal to 0.85, and X is equal to 3. Okay? Now I'm not going to tell you, there's how you plug it in. I'm not going to go through that because that's a pain. But I will tell you how to do it on your handy dandy calculator. And if you need it, it's under binomial PDF, which is under second vars. I was going to see if the book tells you, but it should. Let's see if it tells you on the next page. Or the next page. The second vars binomial PDF. But I'll show you how to get there. I guess they don't show you. All this time I thought they had. There it is. Second vars binomial PDF. Okay, there it is on page 217. So you take out your handy dandy calculator. And you hit second vars. Second, which is the yellow top left corner. Vars, which is right beside the clear button. Binomial PDF, which is number 0. Now, since the beginning of this section, I've been saying NPX, 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 NPX. One of the reasons I've been saying NPX over and over and over is because that's the way you have to type it into your calculator. If you type it in any different way, it's going to give you an error or an error depending on where you're from. But you got to type in N, P, and X. Now in the previous example, N was equal to 5. So you type in 5, comma. P was 0.85, I believe, wasn't it? Yes, Hubert. Thank you, class. And P was, or X was 3. Will X always be less than N? Yes. And close parentheses. So, sorry. Oh, Hubert, don't use the keyboard. Use the calculator. Thank you. All right. So, we have a coin that we flip 5 times, and out of those 5 times, we got an 85% chance of tails. What is the probability if we flip that same coin 3 times? That's what it's asking. Of course, it's got a different example. I don't know what they're talking about, but I'm giving you an example that you can put in your brain. We flipped a coin 5 times. Out of the 5 times, we got an 85% chance of tails. What is the probability if we flip that coin 3 more times? What is the probability of getting tails? And that probability is 14%. Of course, you're talking about 3 times, you know. So that's not a very good example as far as percentages go, but you still see what I'm trying to get at. I'm trying to give you something to grab onto as far as an example. All right. So the only thing you have to remember on this is make sure you type NPX in order, because if you don't, you're going to get an error. So let's try nerd. Let's try one in your 5.3 study plan. All right, here's an easy one. Assume that the procedure yields a binomial distribution with n is equal to 6 and a probability of success of p is equal to 0.8. Use a binomial probability. No, you don't need a binomial. You just do a calculator to find the probability that the number of successes is 2. So n would be what? P would be, and x would be 2. So you pull out your handy dandy calculator, hit second function, entry, change that to, I done forgot, 6.8 and 2. 0.015, so that'd be 0.015. It's a miracle. Golly, I can't believe they still have the tables in here. Dango, let's see, 0.8. You'd find 0.8 right here. And out of 5, 6, I'm showing you how to use the table. Let me use my handy dandy whiteboard. Go away. Alright. I'm going to try to do this, but I don't know if it's going to work or not. Alright, so you find n is equal to 6 right here, this little area right here. And x is what? 2. So you use this tape. I tried. Let me try right here. You're going to use this area right here with the n is equal to 6 and x is equal to 2, and then you're going to take your handy dandy vertical virtual vertical line and go at 0.8. And what did we get? 0.015. Let's see what our answer is. Go away. 0.015. Now that's how you use the table. And I would highly suggest using the table if you don't have a TI app versus using the formula. Alright, let's try one more so you'll have it in your notebook. So when I give you 3 or 4 on the test, at least you'll get those right. Now don't fall into the trap here, because the trap is they give you N, X, and P, and y'all going to type in N, X, and P, and the calculator is going to have a fit. Because N, P, and X, it's looking for probability, and probability cannot be 2. Why? It's supposed to be 0 to 1, exactly. So it can't be 2, so the calculator is going to have a heart murmur because of that 2 right there. So you're going to flip these 2. So you put in your handy dandy calculator, second function, enter, and type in 6.15 and 2. 0.176. There's a test question. It says a TV show, Lindsay and Tobias, recently had a share of 20, meaning that among the TV sets in use, 20% were turned to that show. Assume that the advertisers want to verify the 20% share by conducting its own survey. And a pilot survey begins with 18 households. What do you think that 18 is? N. 18 is N. Well, what about the 20? That 20, that's nothing to do with the problem. Because what does it say? Assume that an advertiser wants to what? Verify. So you're going to verify that 20% is what you're going to do. Alright? By conducting its own survey, and a pilot survey begins with 18 households having TV sets in use at the time of that TV show broadcast. Find the probability that none of the households are turned to that TV show. So what do you think? Well, N is going to be 18. Where is the only percentage in this question? 20%. So P is 20%, 0.2. And then what's the only other number you can use for X? 0. Simple as that. This is a test question. 50% of students miss it. So take your handy dandy calculator, second function, entry, and dang old 18, thank you. 1, second function, insert 18, and 0.20, and 0. So does this show really suck? I guess not, because 2% will, out of, 18 houses, only 2% are not watching it. So it says around 3 decimal places. 0.018. That was difficult. Find the probability that at least one. All right, I want you to do this one. I'm not going to give you any hints. Because I want to see how many of you know what the definition of at least one means. Because a lot of you don't. You don't need to raise your hand or anything. Just at least one. If you don't know what the definition is, draw a number line. Dang old number line. That's what I want to draw. Hold on. There we go. Dang old elementary school. I suck at drawing with a mouse. Zero, 1, 2, 3, 4, 5. I forgot this thing don't automatically orient itself. Only one in this building is in 236. This room is jinxed. Alright. So 1 right here. At least one. What does at least one mean? That means that the lowest number is what? So that means that we need to find the probability between 0 and what? I'm trying to get there. Hold on. What's the other number? 0 and what? 18. So you need to calculate each one. You need to calculate npx with x is equal to 1, npx with x is equal to 2, npx with x is equal to 3. You got to do that how many times? 18 times. Right? Or you can do the probability of 0 and take it away from what? 1, Hubert. That's right. Because what's the only other number? Can you have -1 households? No. So these don't. Just throw these away. Okay? Alright. So, let me fix this because this is driving me bananas. Still ain't going to be right because this. Your population is from 0 to what? 18. You want to know. You want to know from from 1 to 18, right? So this whole probability is equal to 1, right? So if this whole probability is equal to 1, then why can't I just take the probability of 0 and subtract it from what? 1. Can you have 1.5 households? No. These are all whole numbers. There is no probability in here, okay? Because you can't have 0.5 households. 1 household, 0 households, 1 household, 2 households, and so on. So the easiest way to do this problem right here would be 1 minus the probability of what? 0 households. I guess somebody came in here and messed up the board. Okay, so 1 minus 0.0, 1 minus the probability of 0 households. unless you want to do 18 calculations. So we're going to take our handy dandy calculator. I don't know if this will work, but I'm going to try it. Turn it on first, Hubert. 1 minus inverse answer. Yeah, I don't think it's going to work. Sorry, forget it. Let me just clear it. No. Second entry. And I'm going to do, how many households? 18. So 1 inverse insert 18 and 0.20 and 0. And of course we did that right up here, but I'm doing it again. And that's 0.1018. Now, that is the probability of this guy right here. So I'm going to say 1 minus inverse answer, which is the little negative sign beside the enter, and that's equal to 0.982. So my answer for B is 0.982. It's a miracle. All right, you do this one. It says find the probability that what? At most 1. So you need to highlight, on the previous one you need to highlight at least 1. And on this one you need to highlight at most 1. Because that's going to tell you what you need to do. So on this one, at least 1. And this one, at most 1. So here's your handy dandy number line again. And you know you've got from 0 to 18. So what does at most 1? What does at most 1 mean? That means that the highest number you got is what? 1. 1 household. Well, what's the only other number? 0. So that is at most 1. In other words, whatever your base is, which is 0, plus whatever number is at most. So if you had at most 3, it would be 0 plus 1 plus 2 plus 3. If you had at most 5, it would be 0 plus 1 plus 2 plus 3 plus 4 plus 5. At most means that that's the largest number that you have. So the probability of at most 1 would be the probability of 0 plus the probability of what? 1. So we know the probability of 0 is 0.018. Now we got to do the probability of 1. And the probability of 1, second function, enter. Second function, enter. There we go. And I'm going to put a 1 here. And that's 0.081. And I'm going to add 0.018. Dang old transposing numbers. 0.018. And that's equal to 0.099. So we put our handy dandy cursor in there. 0.099. And we put a plus in there so we can get it wrong. Look there. Alright, if at most 1 household, that's right here, at most 1 household, is tuned to Lindsay and Tobias, which is 10%, does it appear that the 20% value is wrong? Okay, 10%, 20%. Is it wrong? Yeah. Now, does it appear that's 20%? Well, let's go back up here. Meaning that among the TV sets in use, 20% were tuned to that show. Okay. 10% is not equal to 20%. So in my opinion, it would be, is this value wrong? Yes. All right. Now, you got to see how much wrong is it? How wrong is 20%? Well, or 10%, whatever the case may be. And in this case, we would take new minus old over old. So somebody take the new, which is 0.099, minus 0.20. I'll do it. 0.099 minus 0.2 divided by parentheses 0.2. I get 0.51. Okay, so that's a 50% difference. And is that common sense, right? 10% versus what? 20%. What's 10% versus 20%? It's half. So I'm about right. 50% difference. That's wrong. Okay. Now, why do you have to check to see how wrong it is? Well, what is your indicator that says that something is wrong? 5%. So we got what? 51%. So ours is wrong. I mean, the 20% is wrong. So you would say, does it appear that the 20% value is wrong? You would say, yes. The probability of 20% rate is wrong because it's more than what? 5%. Now that would be my answer. I don't really have too much confidence in these questions, if you want to know the truth about it. I have confidence in my math, but I don't have confidence in these questions. See? So I don't know what the answer is. I don't understand that. The probability of at most one household is greater than 5%. Okay. I don't agree with this because this says, does it appear that 20% share value is wrong? Now, if they would have said, does it appear that this falls within the 20% share value? Yes. Okay? But the way that it says, does it appear that the 20% share value is wrong? And in my opinion, the 20% share value is wrong. Now, if they use the word within, you see what I'm talking about? If they use the word within, then yes, it's okay. It's not wrong because, yes, the 10% is within the 20%. But they don't use the word within. They say, is it wrong? So, use your own. I don't know about that question. That's kind of like that dang question about the payoff. And that's why we're changing books. So, we're changing books next semester. I got to go to a meeting Friday because of changing books. Well, this is one of the reasons, because this is the question does not reflect what you're thinking. It never says within. It says, is it wrong? Okay? Wrong is very analytical. Either it's wrong or it's what? It's right. And they're saying it's okay because it's within the 20% is what they're saying. So they never ask you if it's within. They just say, is it wrong or right? So just remember what it's asking. I'm not going to hold you too much on that question right there. I care about this. So I tell you what, if you get these three right and get this wrong, I'll give you credit for the whole question. If I got that, but you have to see me if you get it wrong. Okay? I'm not going to go around chasing you. You got to see me on if you got it wrong or not. Okay? All right. Another test question right here. So write this one down and then we'll move on to 5.4. I told you chapter 5 is going to be real quick. It's a short test, 10 questions maybe. Okay, it's real simple. Calculator drill team people, y'all probably make an A on it. regurgitate. Calculating. All right. This one says, when someone buys a ticket for an airline flight, there is a 0.0971 probability, there's a 10% chance that the person will not show up for the flight. Can you imagine not showing? How much is a plane ticket? Exactly. All right? Not show up. I believe I would show up half sick if I spent $125 on the plane ticket. But anyway, a certain jet can seat 22 passengers. Now this is very important because some people go, is it wise to book 24 passengers for a flight on the deck? And they'll use that 24 incorrectly. All right? I don't care if 24 people show up or not. How many people are going to get on the plane? 22. Okay? I don't care if the guy has a gun. All right? He's going to have to stand up because there's only somebody's going to have to stand up because there's only 22 seats. Now that's very important for you to realize in this problem because people focus on the 24 when they should be focusing on the 22 because 22 is the main number. Unless you sit in the restroom. Okay? That could be 23 and 24 right there. All right. So finish the problem. It says determine whether or not booking 24 passengers for 22 seats, well, they say it right there, on a jet is a wise decision. Select the correct choice, blah, 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 blah. Okay, take a minute and work that problem. Is it going to rain today? Or is it raining? Oh, it was. So in this case, n is equal to 22, right? Okay, n is equal to 22, and p is equal to, now watch it here, because when someone buys a ticket, there is a 0.09 probability. So that's the probability of a person not showing up. What is the probability of a person showing up? The complement of 0.0971. So you need to take 0.0971 and you need to take that away from what? 1. So do that. Okay? And then use that for your P. And then what's your X going to be? Your X is going to be 24 and 23. Why? Because that's the number of seats that are what? Over 22. You can only put 22 on the plane. You want to know the probability of the 24th person showing up and the 23rd person showing up. That's what you want to know. And that's why you do it that way. So take your handy dandy calculator. And let's do second function, enter, second function, enter, second function, enter. There we go. Excuse me. So 22. And what is it? Point what? Just give me 2 decimal places. 0.9 what? 903, which is 90. 0.90. Let's go ahead and put the 3 in there because they probably did. 3. And probability of 23 showing up. Close parentheses. 0%. That can't be right. Put in 22 and see what happens. I may be doing it that way. Okay, let me get out of this. Go away. Thank you. Second function, entry. Let's put in 22. They may be taking it from the other side. 0.11%. So 11% chance. There's 11% chance of 22 showing up. Yeah, that's what they're doing because you can't have 0%. Where you type in the answer. You don't even type in the answer? Alright, it says determine whether not booking. Okay, this is what they can't, the people that want to change the book, that they can't stand the way they were. Determine whether or not booking 24 passengers for 22 seats on the jet is a wise decision. Select the correct choice below and fill in the answer box of choice of blah, 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 blah. Let's see. It is not a wise decision because the probability of not enough jets on the seat, okay, is. Well, the probability of enough seats is 11%. So not enough would be what? 0.9%. So I would say the probability of not enough seats, I don't think this is right, is 0.9. If you take away 0.105, that'd be 0.895, or that's 6, 0.894, something like that. I would say 0.894, but I don't think I'm going to get it right because I don't think the answer is correct. See, that's 0.3086. And I don't know how they're getting that because they should. Now, if you put in, hold on a second, let me try this. Second function, entry, and instead of putting in the complement, put in the no-shows, 0.097. .097. That is way wrong. So we're putting in the right probability, and that's 0.90. But I'm not coming up with 0.3086 like they are. And you're supposed to put in 22, then the probability of 22, and then the probability. I thought it would be 23 and 24, but that's not right. Unless second function entry, change this to 23, put that as what is it, 0.90? I'm sorry, what? 0.903, and change that to 22, and that would give us that. And then 24, second function quit, second function entry, and change that to 24, and add those two together is how they're coming up with it. I don't know how they're getting it, to be honest with you, because I thought they were going to do it. First, calculate the probability that the flight is overbooked, blah, 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 blah. Okay. Be X is 23 or 24. Well, we said that. And we did that. That's what I thought, 0.903, right? Okay, I'm sorry, 0.9029. And plug in N, P, and X. But they're saying that P of 23, that would be the probability of 23 showing up. N is 24. Did we not type in N is equal to 24? And 23? I thought we did that. And you're supposed to add them up. Okay? So let me do it again. I thought we did that. We did it both ways. So 22, second function, entry. I think we should quit. 22, and X is equal to, or did they say N? Okay, we did that too. Oh, they won't know 24 shows up. 23 and 24. So put a 23 in here and a 23 in here. Alright, write that down. 0.095. And let's see what 24 and 24 is. That's probably what they're doing. I hadn't done this problem in a long time. Let's do. You know, when you can't work calculators, time to quit. Second function entry. Try 24 and 24. I know I don't use a calculator very much. That's still not going to give you the answer. Well, let's see what they say type in. 23.0956. 0.0956. And we got 0.0864. 0.0864. And they gonna get those numbers, 0.22224 and 0.08. Okay, now we must be typing in something wrong because those two are right on the money. So I must be typing in something wrong. I ain't gonna worry about it today.
Let them be 24.
What?
Let them be 24 for both 23 and 24 and see what happens.
Let's try that. 23 and 24.
So you go back to 24.
All right, let's try that. Second function entry
You just take that last one.
changes to 23. There it is. That's it. I'm sorry. Yep. N is 24 on this problem. I don't know why, but N is 24. 0.903 is P, and X is 23 and 24. So then you type in the next thing, second function. I'll try not to give you this one on the test. How about that? And that's that one right there. So, all right, that's good. That's a good way to end class. Let's end on that one.